Okay, on this problem, it says, listed below are systolic blood pressure measurements obtained from the same woman. Find the regression equation, letting the right arm blood pressure be the predictor variable and the best predicted systolic blood pressure in the left arm, given that the systolic blood pressure in the right arm is 80, use the 0.05 level so it's round to the nearest whole number. Okay, I know it's hard. You read this and you go, oh my goodness, what am I even supposed to do here? Here's the key, regression equation. Find the regression equation, right? So in other words, this is X, and this is what it says it right here. Right arm blood pressure is X. Okay, so let's see, X is right arm blood pressure. Okay, so, find the regression equation. Where's that? Go to the notes. Here's the exam 4 notes. Linear regression, right here. Linear correlation, linear regression, same thing. Regression, correlation, those are synonymous. It even says regression right here. Linear regression equation, that's what they asked us to find. So what do? Put the data in L1, L2, linear regression t-test. Okay, so this is L1, this is L2, and then go stat, tests, down to its F, linear regression t-test. Okay, so I did that, and when you do that, you're going to get X list, which will be L1, Y list, which is L2, frequency, which is 1, and then there's B and P thing. That's not equal to 0. How do we know that? Notice on the notes here, for HO, it's equal to 0, and H1, it's always used not equal to 0. I just added that to the notes. So if that's an update to the notes. You may or may not have the most recent update to the notes. If you don't, add that into your own notes. That'll help you. Always use not equal to 0, except if it specifically says negative, use less than 0, positive greater than 0, but it's almost always using not equal to 0. Ours doesn't say negative or positive, so use not equal to 0 there. And go down and calculate. Okay. When you do that, what you get is the following results. You get, your calculator spits out y equals a plus bx, and then it tells you what a is. If you go down, my a says 80.638. That's my a. It tells me a is that. And if I move the calculator down, it tells me b is 0.907 x, right? So it puts at the top of the screen y equals a plus bx, and then it tells me what a is, it tells me what b is. So there's my equation. Now, what does it say down here? It says if the p-value is less than alpha, and my p-value is low. I didn't see, my p-value is 0.01. Yeah, I'll write it up here. My p-value is 0.0101, and that is certainly less than alpha. 0.05 right there. It's less. And so what does that mean? So the p is less, my p-value is less. It says here, if the p-value is less, mine is, then there's strong evidence that the two variables have a linear relationship. On the graph, the dots do fit a line. So we can use the linear regression equation. So when given an x value, plug it in to find the y value. Oh, so we can use this. And we no, did they give us this? Yeah, right here. Right arm 80. X is right arm. Right arm 80. That's saying X is 80. Plug it in right here. You see, Y is 80.638 plus 907 times 80. Hit the buttons on your calculator. And I'm getting 153.198. They said whole number, round to the nearest whole number. So we'll just say 153. So there we go. Did you follow that last part? So they told me regression equation. So I went down here linear regression equation. So that means I put data in L1, L2, linear regression t-test. HO is 0. H1 always use not equal to 0 unless they specifically say negative or positive, which they almost never will. That's why I say always not equal to 0. And then, so we did that. We put the L1, L2, linear regression t-test, L1, L2, not equal to 0, calculate. We got y equals a plus bx on our calculator. It told me what a and b are, so I put those in. And then right here it said the right arm is 80. And the right arm is x, which it says right here. X is the right arm. So the right arm is 80, x is 80, plug in 80, work it out in your calculator, and it even says it right here. So when given an x value, plug it in to find the y value, which we did. And what is that really saying? This is saying, this is how patients write, and this is one patient, their right arm and their left arm blood pressure. Looks like the left arm is always higher because that's the side where your heart is at. So therefore there's a connection, right? People that have a lower right arm also have a lower left arm, and higher goes with higher, right? So now we can use this equation to predict a patient who has an 80 right arm, what will they have in their left arm, right? If the X is 80, right arm is 80, what's their Y going to be? What's their left arm going to be? The Y is going to be about 153. Somebody has an 80 in the right arm, it's going to be about 153 in the left. It connects X and Y. We just found this equation that calculated it, connecting X and Y. Right? If you did this on a graph, you'd have a bunch of dots and they all fit a line connecting X and Y. So if you know somebody's right arm, you could predict their left arm using this equation. That's what we just did. There we go.